In this lesson, we're going to be introduced to the formula used when calculating heat change in a phase change or a chemical change. The amount of heat released or absorbed by either a phase change or a chemical change will depend on several factors. Those factors would be the moles of a substance and the molar enthalpy of the phase or chemical change. This brings us to the formula Q is equal to N delta H. Recall from Chemistry 2202 that the number of moles is equal to the mass divided by the molar mass. Let us go through example number 1. Calculate the amount of heat required to melt 50 grams of ice. Melting is a phase change, and this is how we know we need to use Q is equal to N delta H as opposed to Q equals C delta T or MC delta T. This example is asking us to calculate the amount of heat, which is represented by the letter Q. And since we know we're undergoing a phase change, we're going to use Q is equal to N delta H. We also know from 2202 that number of moles is mass divided by molar mass, so we can change this to Q is equal to mass divided by molar mass times delta H. Likewise, you can calculate the number of moles off to the side and plug that into N delta H. We were told that we had 50 grams of ice, and ice being water, the molar mass is 18.02 grams per mole. We must now look up the delta H for the melting of ice. That is on your formula sheet. And when you look that up, it's 6.02 kilojoules per mole. When we multiply this together, grams cancels, moles cancels to leave us with an answer of kilojoules. And to three significant figures, that would be 16.7 kilojoules. Example number 2. Calculate the heat change that should occur when 10.4 grams of calcium chloride is formed from its elements. This indicates that the calcium chloride is undergoing a chemical change, and therefore we must use Q is equal to N delta H. Additionally, you'll notice in both example 1 and example 2, a delta T was not given. There's no change in temperature, which now doesn't allow us to use Q equals MC delta T or Q equals C delta T. We've also been asked to calculate the heat change, which is represented by Q. So we have Q equals N delta H, which we can use mass divided by molar mass, delta H. We also have to ensure that we know how to write the formula for calcium chloride in order to get the appropriate molar mass. Calcium is Ca2 positive, chlorine is Cl negative. So if you do the crisscross from Science 1206, this would be CaCl2, and that's what you'd have to get the molar mass of. So we have 10.4 grams divided by the molar mass of calcium chloride, which is 110.98 grams per mole, times its delta H, which is given. Notice that in the question, we are talking about when calcium chloride is formed, and we've been given the delta H of formation. So we can use the number given, which is negative 795.4 kilojoules per mole. Here, grams cancels, moles cancels, to give it an answer to three significant figures of negative 74.5 kilojoules. Example 3 states that a 5-gram sample of benzene was burned at standard ambient temperature and pressure conditions, resulting in the release of 209.2 kilojoules of heat. Since the benzene is burned, this undergoes a chemical change, and therefore we use Q is equal to N delta H. However, in this question, we've been asked to calculate the molar heat, which is delta H, so we must rearrange this formula. For delta H is equal to Q divided by N. Off to the side, we can calculate the number of moles as mass over molar mass. We were told that we had a 5-gram sample of benzene, and we were reminded that benzene is C6H6, which has a molar mass of 78.12 grams per mole. Grams cancels to give us an answer to three significant figures of 0.0640 moles. Of course, you can also do this within the formula. We were told that we released 209.2 kilojoules of heat. Therefore, we're going to represent that as negative 209.2 kilojoules to show that it was released. And we just calculated the moles to be 0.0640 moles. Getting an answer to three significant figures, it's negative 3.27 times 10 to the 3 kilojoules per mole. That represents the delta H of this reaction. At this time, I strongly encourage that you practice the questions on the following worksheet.